Okay, we're back. We've got the last lecture of the course, I believe. We've already done timber posts and columns with a load on center. I kind of explained to you what off-center was, and if you've got your book, page 250, the letter B on figure 6.5 is exactly what I was talking about. So, we've got a load that's off-center. So I've got a post or a column with a load that's off-center. The distance between the center of the post and the center of the load is eccentricity. Eccentricity literally means off-center. Okay? So now we've got introduced bending. So when I take stuff and put it off-center, not only do I have a load going through, I have a load and a moment, where the moment is the force times the distance. So I've got a load and a moment. And when I have a moment, that's exactly what's in a beam. I have bending. So now we're under a condition where we have axial load with a bending. So now I've got to have an interaction formula which kind of ties the two together mathematically to get us in a position where we can evaluate whether that load and that distance create a problem. So let's do it. If you have your book, the whole lecture is going to center around page 250, the very bottom. Investigation of columns with bending, ASD, allowable stress design method. So we're not going to use the load and resistance factor method, the allowable stress. That's typically what's used with wood. Wood and dirt are allowable stress. Concrete and steel are load and resistant. So I'm going to write down the formula. This is more, once again, it's empirical. We talked about that. It's more of populating the equation than understanding what the equation is physically doing, because this was done by somebody pretty smart sitting in the lab. So I'm going to take and put this equation up here. We're going to do a problem when we get done, and that problem is going to be 6.5 series. So when I get to it, we'll find out which one you're doing, and I'll do the other one. So let's do it. I'm going to do 6.5D, it looks like. So here's your equation. It's inequality. The part on the left has to be less than or equal to 1. So it looks like this. FC prime squared plus FB 1 minus FC over FCE. Okay, I think you've seen all these letters except one of them. I think you've seen little FC, little FB, big FB, little FC. We just calculated in the last lecture FCE. So you've seen that. And this guy you haven't seen, but you've seen the components of that. Okay? So if I wrote the components of this down, this guy right here, FC prime is equal to FC star, which you've seen, times C sub P. Okay? And you've seen both of those. So there's nothing new here. It's just how do I use this data? And I'm gonna put a laundry list over there on the right-hand side before we're done. And the laundry list is the data you need to collect and where to collect it in order to fill in the blanks in this equation. So let's look at the letters. FB, FC, FB, FC prime, FCE. So if I go through this, there's FC is there and there. Got that one. FB is here. Got that one. Big FB is there. I've got that one. FC prime is there. I've got that one. FCE is there. I've got that one. Okay, let's see how we're going to continue now. I'm working my way to the right. When I get done, I'm going to have a laundry list for you. FB, you've already done this. We did it back in a couple of the YouTubes, in a formula I put on one of the videos we prepared. This is MC over I, and this is P over A. Okay, where'd this come from? Chapter 2. Where'd this come from? Chapter 3. You already know what those are, so hopefully you got them. And then this also equals M over S. Section modulus. Take your pick, okay? Okay, I'm going to take this a little further. BFB is direct, so that's table 5.1. That's a direct read. This is FC star times C sub P, and this is equal to 0.822 E min divided by LB over D squared. Okay, we're getting there, slowly but surely. So I'm going to get to the right-hand side here shortly. So it looks like FB is comprised of M, which is either M or P times E, depending on how the problem is stated. So we got that. We've got C, and we've got I. Here we've got P and A. FB is all set. Here we've got FC star. That equals FC times table 5.2. That was done before. That was the last lecture. E min, LB, and D. Okay, so we're getting close now. We're getting to the end of the rope. What are we going to do with this stuff? Looks like I'm pretty good shape right down that list. So I need P. There's P. P is here and here. I need C. I need I. I need A. I need FC. I need table 5.2. I need C sub P. I need FC star and FCE, so I've got both of those, so I don't worry about that. And now I move down to table 5.2. I need E min, I need LB, and I need D. Okay, so in my mind anyways, if I've got that last row filled in, I've got everything I need to complete this process. So I'm going to go ahead and I'm going to fill in that last row. And once I do that, then I can just put the numbers back in. So let's look at problem 6.5D. Okay? 6.5D. And I'm going to tell you where to get this data as I talk. 6.5D is on page 255. And I'm going to go with it. It's a 12 by 12 column. 12 by 12. It's Doug Furlart's number 1. It's 12 foot long. It's got 24 kips. The 24 kips is placed 9.5 inches off center. Investigate the column for combined compression plus bending. Okay, I'm going to circle these based on where I get them, okay? And hopefully it makes sense. Okay, I'm going to use green for the problem. If I read the problem, I should get this. Oh, I forgot E up there. Doggone it. There's E right here. Let me put him up here. E, P, C, I, P, A, F, C. I'm good. I'm good. I think I'm good now. Okay, green is read the problem. Those are direct reads, okay? And for my problem, E here is 9.5 inches. P here is 24 kips, and I'm going to write it as 24,000 pounds. That takes care of this guy and this guy. LB, 12 feet. And I'm going to change it right here. 12 feet equals 144 inches. Okay. Now, the next set is cross-section. I'm going to make this blue. So anything associated with the cross-section. The cross-section is a 12 by 12. So, this is cross-section, 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 and cross-section. So that's a 12 by 12. What is C? C is the distance from the neutral axis to the outside edge. That is half of the width of the member itself. So let's go. Let's take a look at it. I'm going to do that, or I can use S if I want to, and that may be easier for you. These two combined is equal to S. That may be a lot easier for you, okay? MC over I is S. See right there? S. So these two combine for S. So if you just want to look up S, that's great. So let's go to the table. I'm going to the back of the book. Where's the blue from? It's 676677 A8. So the blue is from A8 676677. I'm going to go back there. I'm going to look up a 12 by 12. Okay, I'm back there. I'm on page 677. I got 12 by 12 in sight. It's 11.5 by 11.5. So that's 11.5. The least of the two. Takes care of that one. The area of a 12 by 12 is 132.3. 132.3 square inches. The S of a 12 by 12, and we will be using the X column. 12 by 12, S, 253.5. 253.5 inches cubed. Okay? That looks like it's pretty good to me. Now, I got to use the table 5.1, and that'll be red. Red will be table 5.1. And that's a function of this. It's number 1. It's a 12 by 12, and it's a post. So go back to your table, and we are on Got to find my table here. 5.1. There I am. Okay, I'm posts and timbers. I'm number 1 dug for larch. And I want FC. Oh, I missed FB. Table 5.1 right here. I'm going to put him over there too because we need him. And he comes from table 5.1. So we got 3 things to grab while we're sitting around here. So let's grab those 3 things out of the table. I'm posts and timbers because I'm greater than 5. I'm number 1. I walk across. The first dial I get to is FB is 1200. FB is 1200 PSI. Okay, keep going. I go across. I hit FC. FC is 1000. I keep going. 1200, 1000. 580,000 is E-min. Okay, I'm pretty well there. All I got to do is see if there's a value associated with table 5.2. And what did we say last time? Hopefully you remember. If it's 2 to 4 inches, I use the table. 2 to 4 inches. If it's greater than or equal to 5 inches, I just use exactly the same thing as FC. So this now, according to what I've just said, becomes FC star. If not, there is nothing here. Greater than or equal to 5, no table. Okay, I think I can do my thing now. I think I got her whipped. Okay, let's see. Let's populate. Okay, is there anything I can throw into this equation right off the bat? Looks like yes, I can do this. Okay, takes care of that guy. He's gone. Anything else? Direct. Doesn't look like it. Yeah, there's another one maybe. No, there isn't any more. No directs. So let's go. What am I going to calculate? Let's go FB. M over S. M is P